To the casual observer, Mars looks unremarkable, a frozen rust-red world adrift in space. But take a closer look and you start to realise Mars is weird, really weird. It's a planet full of contradictions. One half looks smooth and untouched, the other cratered and chaotic. It's a strange duality and it's known as the Martian Dichotomy, and it might be the biggest geological mystery in the solar system. So let's find out, how did Mars end up with such a dramatic divide? Much of Mars's northern hemisphere is dominated by vast low-lying plains, wide flat expanses that stretch to the horizon, such as in Sidus Planitia. Here the terrain is smooth with few craters, making it look geologically younger, at least compared to the south. Rather than a cliff, the boundary rolls like a giant ramp, a gentle continent-wide slope easing down into the northern plains, a shape that's strangely unique among known basins. And the lack of ancient craters suggests something erased them, as if some process began reshaping the region but never finished. Its low elevation and smooth terrain have led some scientists to wonder, was this once an ocean basin, a place where shallow seas gathered and life might have begun? But whatever stability it held, it didn't last. The southern hemisphere tells a different story. Its surface is older, rougher, more scarred, with billions of years of impacts having carved the shattered landscape, where craters cover a surface twice as thick when compared to the north. Some of Mars's most iconic features lie here, including Valles Marineris, a canyon system so vast it stretches across a quarter of the planet's circumference. Scientists suspect it was not carved by rivers but likely torn open by tectonic forces, creating walls that plunge up to 7 kilometers deep. If the north is defined by its smoothness, then the south is its opposite, a scarred, craterous, mountainous region. A battered landscape that has endured for over 4 billion years, with an ancient crust still bearing the marks of a turbulent past, preserved by the stillness of a planet that no longer renews itself. And yet, when north meets south, there's no middle ground, no smooth handover, it just falls away. Fractured escarpments stretch for thousands of kilometers, with continental scale cliffs plunging 5 kilometers deep, leaving behind the scar that defines the planet's dual identity. But what could carve a planet like this? What kind of forces could create a world split in two? Scientists still debate how the Martian dichotomy came to be, but two leading ideas have emerged. One begins with a single act of unimaginable violence. Around 4 billion years ago, a massive object, maybe a small protoplanet, struck Mars. The blow tore away much of the northern crust, leaving behind the Borealis Basin, a scar over 8,500 kilometers wide, and it's the largest known impact basin in the solar system, a wound so vast it's as if half a continent simply vanished. This theory explains a lot: why the northern crust is so thin, why the elevation is so low, and why the surface is so flat. But there's a problem. For something this massive, the evidence should be obvious. If a colossal impact really happened, it should have left scars. Scientists have searched the northern lowlands for clues such as shattered minerals, melted rock, deep fractures. But the surface remains strangely smooth. No impact melt, no high pressure minerals, and no deep scars. It's as if the basin was swept clean. Maybe the clues are buried beneath volcanic plains, erased by ancient eruptions, hidden by dust or worn down by wind. Or maybe something else happened. The surface of Mars tells one story, but its core tells another. Scientists believe that deep inside the planet, a massive plume of molten rock surged from the mantle, lifting the land in the south to create the divide between Mars's two hemispheres. The result? The Tharsis Rise, a vast volcanic plateau that stretches thousands of kilometers, crowned by Olympus Mons, the tallest volcano in the solar system. This internal upheaval, known as the mantle plume hypothesis, suggests Mars's southern crust swelled from below, pushing later geological activity north and sharpening the divide between the hemispheres. But the theory has its problems. Mantle plumes don't usually leave behind such sharp planetary scale boundaries. Mars' divide is too clean, too sudden. It's as if two different stories collided, and neither is complete. Maybe that's because Mars wasn't shaped by one force, but by two. From orbit, the split is undeniable. From history, its meaning is still unclear. So why does this matter? Because the Martian dichotomy might be more than a mystery, it might be a eulogy written in stone. Whether sudden or slow, the result may have been the same. Mars's core was disrupted, its magnetic dynamo died, the planet lost its shield, solar winds stripped the air, water boiled into space, and Mars was left exposed. Two paths, same outcome, a planet brought to stillness, and if life ever tried to take root here, the dichotomy may have been the moment it slipped away. Mars remembers what it almost was, and we are left reading its scars.